रोटेशन चेंज नहीं हो पाएगा, कोई बात नहीं, कोशिश करेंगे. See, so we will continue the next subtopic, uh, ray of lights, ray optics and optical instrument is that refraction through a prism. Yeah, you can see this is the prism and this is the angle I. Okay, after reflecting, okay, you can see. So next one we will continue. And the passage of the light through a triangular prism ABC. The angle of the incidence and refraction at the first phase AB and I and R1, while the angle of the incidence from glass to air at the second phase AC is R2, and the angle of the refraction or emergence E. This is the angle E. Okay. The angle between the emergent ray RS and the refraction of the incident ray PQ is called the angle of the deviation delta. Okay, we call as delta this sign. In the quadrilateral AQNR, okay, AQNR, okay, this is the making a quadrilateral. So two of the angles at the vertices Q and R, the right angles. Therefore, the sum of the other angles of the quadrilateral is 180 degree. Angle A plus angle Q and R equal to 180 degree. A plus Q and R. Okay. From the triangle Q and R, R1 plus R2 plus angle Q and R is equal to 180 degree, and the comparing these two equations, we get R1 plus R2 is equal to A. The total deviation delta is the sum of the deviation at the two faces. Delta equal to I minus R1 plus E, okay, minus R2. Okay. So next one, in this delta equal to I plus E minus A. So thus we can say the angle of the deviation depend on the angle of the incidence. A plot between the angle of the deviation and the angle of the incidence is shown in the figure 9.22 in the next page. Okay. In general, any value of the delta except for I is equal to E corresponds to the value I and hence of E in fact is expected from the symmetry of I and E in equation 9.35, where delta remains the same if I equal to the next one, and E are the interchanged physically in this related, and this is the figure in which we will see the plot of the angle deviation delta versus angle of the incidence I for a triangular prism. Okay, see, this is the x-axis, this is the y-axis, 0 degree, 20 degree, 40 degree and 60 degree, E dash 80 degree, 30 on y-axis. This is the angle of deviation which we call as delta. Okay, in fact, this is related that the path of the ray in, okay, traced back resulting in the same angle of deviation at the minimum deviation dm. Okay, so next we will see at the minimum deviation dm, the refracted ray inside the prism becomes parallel to its base. We have delta is equal to dm. Okay, delta is equal to dm. I is equal to E, which is implies R1 is equal to R2. Okay, so 2R is equal to A and R is equal to A upon 2. Okay, so we can see that in figure, equation 3.2.935. That means dm is equal to 2I minus A, where I is equal to A plus dm upon 2. Okay, the refractive index of the prism is n21, n21 equal to n2 upon n1 into sine A plus dm upon 2 upon sine A upon 2. This is also a formula. So we can see the angle A and dm can be measured experimentally, equation, okay, in this equation. Thus provides a method of the determining the refractive index of the material of the prism. Okay, for a small angle prism, that a thin prism dm is also very small, and we get n21 is equal to sine in bracket A plus dm upon 2 upon sine A upon 2 will equal to sine cancel A plus dm upon 2 upon A upon 2. So after all, dm equal to n21 minus 1 into A. It implies that thin prism do not deviate light much. Okay, so next one, the next subtopic is optical instrument. We will see optical instrument. A number of the optical devices and the instruments have been designed utilizing reflecting and the refracting properties of the minors, lenses and the prism, periscope, kaleidoscope, binoculars, telescope, microscope are some example of the optical devices and instruments that are in common use. Our eyes of course, one of the most important optical device the nature has evolved with us. We have already studied about the human eye in class 10th. We now go on to describe the principle of the working of the microscope and the telescope. The first one is microscope. We will continue with microscope. Thank you for watching.